Hi guys, welcome back to lesson 29-1, day 2. This one is going to be about multiplying and dividing rational expressions. So you will want your lesson 29-1, day 2 note sheet and a pen or a pencil and your calculator. And as I mentioned, we are going to multiply rational expressions, divide rational expressions, and be still identifying, the excluded values of rational expressions. So let's get started. So if we look here, multiplying has very similar steps as simplifying. We just kind of have to do a little bit more factoring. So basically you have a rational expression and a rational expression, and they're being multiplied, okay? So what you want to do is go ahead and factor both numerators and both denominators, and then anything that's on the top and bottom that is the same, you can cancel, and whatever's left will be your final answer. Now, we do have to look at both denominators for the restrictions, okay? So that's what they did here. In this first numerator, they took out a 2 and they were left with 2 times x, and then it was x squared minus 4. So that was a difference of 2 squares. So they wrote that as x plus 2x minus 2. So that one was good. Then here they had x squared minus 1. So that's a difference of 2 squares. So they wrote that as x plus 1, x minus 1. Okay. Here they had to do the big X because they had x squared plus 2x plus 1. What two numbers multiply to 1 that add to 2? 1 and 1. So they wrote that as x plus 1, x plus 1. Good. And then in this last one, the last denominator here, you can take out an x, and then you're left with x squared minus x minus 2. So they had to do the big X again. And figure out what multiplies to negative 2. Oops, that adds to negative 1. And that should be negative 2 and positive 1. So that's where they got the x, x minus 2, x plus 1 here. Okay. Then what they did for the restrictions is they have to set all of these equal to 0. So the first one, they get negative 1. Then this one, they get positive 1. The x, you get 0. This, you get positive 2. And then this one, you get negative 1 again, but that's already written, so you're good to go. Okay, so they still did all their restrictions. And then they canceled out anything that was the same on top and bottom. And they wrote what was left, which was this 2 times x plus 2 and x times x minus 1. And that's your final answer. Okay, so let's try one. So let's take a look at this first numerator here, and we are going to factor 2x plus 4. So the only thing we can do here is take out a GCF of 2, and we'll be left with x plus 2. Okay, then let's look at this denominator here. So you have x squared minus 25. So that's a difference of 2 squares, so that can be written as x plus 5, x minus 5, right? Take the square root of each one. Oops. Okay, so the first rational expression is done. Then remember, we're multiplying. And now if we look up here, we need to do the big X. So what two numbers multiply to negative 50? That add to negative 5. So you should be looking at negative 10 and a positive 5, right? Negative 10 times 5 is negative 50. And then negative 10 plus 5 is negative 5. So let's write those here. So we have x minus 10 and x plus 5. And then in this last one, I would take out a 4 first. And then you're left with x squared minus 4. And so I would rewrite that as this is a difference of 2 squares. So let's rewrite that. I would rewrite this here. And we have the 4 out front, and then your difference of 2 squares can be simplified to x plus 2, x minus 2. Okay, so that is step 1. We have done all of our factoring. That's the step that takes the longest. Okay, Now what we need to do is set each of these denominators equal to 0. So we do x plus 5 equals 0, x minus 5 equals 0, 4 equals 0, which that's not true, so that actually does not come up with 1. And then x plus 2 equals 0, and x minus 2 equals 0. Okay, so this is going to be x cannot equal negative 5 when we subtract that 5 over. This one's going to be x cannot equal positive 5 when we add the 5 over. Again, that's nothing. This is going to be x equals negative 2 when we subtract that 2 over. And this is going to be x cannot equal positive 2 when we add that 2 over. Okay, so there's all of your restrictions. And now here's the fun part where you get to cancel. So we've got an x plus 2 and an x plus 2. We've got an x plus 5 and an x plus 5. And then we also have this 2 over 4. So if you notice, we have a 2 and a 4. So 2 over 4 is going to simplify to be 1/2. So I'm actually going to simplify that here as well. Okay, so on the top, what's left is this 1 and this x minus 10. So we're just going to write that as x minus 10. And then what's left on the bottom is this 2 and this x minus 5 and this x minus 2. Okay, so I'm going to write all of that here. And I know it's not as simplified as what we're used to, but that's the most that we can do. So that would be our final answer. And then we would just say x cannot equal, and we're going to just list our restrictions from step 2, which was in green here. And that would be your final answer. Okay. So it's the same as simplifying. You're going to do all your factoring. Then you're going to look at all your denominators and state your restrictions. And then you're going to cancel things out to simplify. Okay. All right, let's move on to dividing then. And before we do that, I want to do a quick review of how to actually divide fractions. And what I will say quite often is that you skip, flip, and multiply. Skip, flip, multiply. Okay, and we've talked about that before. So that means you're going to skip this first fraction, meaning leave it exactly the same. You're going to flip the second fraction, meaning literally flip it upside down. So instead of 9 over 8, it's 8 over 9. And then you're going to multiply instead of divide. Okay, so 3 times 8 is going to give you 24. And then 4 times 9 is going to give you 36. And then obviously with these types of fractions, you're going to see if you can simplify. So in this one, we can divide the top and the bottom by 12. So if I do that, divide this by 12, your numerator is going to be 2. And if I divide the denominator by 12, your denominator is going to be 3. So this would be the most simplified version. So basically, instead of just canceling things out, or what we're going to be doing is canceling things out, but this is how you would do it with just numeric fractions. Okay, so why don't you guys go ahead and try part B there. And hopefully you pause the video here. So in this one, you should leave or skip the first fraction, flip the second fraction, and multiply. And here, you could have simplified beforehand if you wanted to. You could have done that in the last one as well, but like 15 or 5 and 15 could be 1 and 3. This could be 1 and 3. So then when you actually go across and multiply, 1 times 1 is 1, 3 times 3 is 9. Okay. Or if you didn't do that, simplify in the beginning, you could have done it like we did the last one, which you would do 5 times 4 and across the numerators is 20. And then you could do 12 times 15, which is 180. And then you would just have to know how to simplify this. So if you were to divide the top and bottom by 20, you would also get 1/9. So either way, whichever way you prefer, that's how you divide fractions, okay? So now let's look at how we divide rational functions, okay? So you're still gonna skip, flip, multiply, just like I said. You're still gonna factor the numerator and denominators. You're still gonna identify the restrictions of the denominators, and you're still gonna cross out common factors. The only difference now is that because we skip, flip, multiply, your restrictions can actually come from both denominators and the original denominator because we flip this one. So there's going to be a few more restrictions, okay? So they went ahead, they did the same thing here. They started out with this rational function divided by this one, and they factored everything. They came up with their restrictions, and then they canceled things out that were the same on top and bottom, as you can see here. And they just wrote what was left. So the 3x plus 2 in the numerator and the 5 in the denominator, and then their restrictions. Okay, so let's go ahead and try one. So in this one, we have 6x squared over 3x squared minus 27, and then that divided by 2x plus 2 over x squared minus 2x minus 3. So the first thing I want you to do is your skip, flip, multiply. That way you won't forget. Okay. So what this means is we are going to keep this first one the exact same. We skip it. So that's going to be 6x squared divided by 3x squared minus 27. Okay. Then we are going to flip the second one. So that's going to be x squared minus 2x minus 3 is now on the top over 2x plus 2 on the bottom. And then, like I said, we are going to multiply. Now it is exactly like the problem we just did. It's a multiplication problem, okay? So we're going to factor everything. So we have 6x squared. Well, that actually cannot be factored, so we're good to go. Leave that one. Then we have 3x squared minus 27. So the first thing I'm going to do is take out a 3, and then I'm going to be left with x squared. Whoops. If I take out a 3, I'm left with x squared minus 9. So I'm going to rewrite that as 3, the 3 I took out, and then x squared minus 9 can actually be written as x plus 3, x minus 3, because that's a difference of 2 squares. Okay, so that's my first one, all factored, good to go. Now let's move on to my second one. Here I'm going to have to do a big X. What two numbers multiply to -3 that add to -2? And you should be looking at -3 and 1. -3 times 1 is -3. -3 plus 1 is -2. So I'm going to write those as x minus 3 and x plus 1. And then last, we have our last denominator here. And so that's 2x plus 2. So I know I can take out a GCF of 2, and I'm left with x plus 1. Now, before you go crazy and you start doing all your canceling, remember you need to come up with your restrictions for both denominators and this numerator because we did that flip. Okay, so because we did the flip, that's why you have to do both of these. Okay, so we have x plus 3 equals 0, x minus 3 equals 0. Also, when I have whole numbers like this, that's 3 equals 0. That doesn't count as anything, so that's why I didn't even write that. Then we also have this 2 equals 0. That doesn't count as anything, okay? Then we have x plus 1 equals 0. X minus 3 equals 0. We already have that, so we're good. We don't need to write that again. and x plus 1 equals 0. We already have that, so we don't need to write that again. Okay, so this would leave us with -3, +3, and -1. That's what x cannot equal. Okay, now we can go ahead and cancel out anything that is the exact same on top and bottom. So we have an x minus 3 and an x minus 3. We have an x plus 1 and an x plus 1. Okay, so all of that gets canceled. In the numerator, we just have a 6x squared left. And in the denominator, we have 3 times 2 times x plus 3. The 3 times the 2 can be multiplied together to be 6. And then we have the x plus 3. Now, this one can actually go one step further because this is technically 6 times x squared and 6 times x plus 3. So those are two different things. So we can actually cancel those 6's. So your final answer should be x squared over x plus 3, where x cannot equal -3, 3, or -1. Okay. Now, remember, we cannot just say this gets canceled. That's not a thing because x squared is different and x plus 3 is part of like a binomial. So you cannot just cancel those. And that's a common mistake that people like to make. Okay. So that is it for today. If you guys have any questions, you can leave them here or feel free to bring them to class tomorrow. Okay. Have a good one. Bye-bye.